Hi, good morning. Welcome back to RS Academy. This is Ravishankar sir, chemistry. In last session, we have discussed how one the topic that is writing and balancing chemical equations. In this session, we are going to discuss how to make the equations more informative. Put it my dear. Making equations more informative. Making equations more informative. More informative. Making equations more informative. So in last session I have given just how to write and balance the chemical equation. But we need to make the equations more informative by mentioning 3 points. That is, one is physical state of the reactants and products. Physical state of reactants and products, and show the change in temperature or heat, change in change in change in heat changing. Next one, reaction conditions. Reaction conditions. The conditions are necessary to take chemical reaction. So mentioning physical state of the reactants and products, and showing change in change in heat, and third one is reaction conditions. So let us discuss one by one. Physical state of the reactants and products. Physical state of the reactants and products. So you must have know that some reactants are in the form of solid state, some reactants in the form of gaseous state, some reactants in the form of aqueous solution. So, if you mention the physical state of the reactants and products while performing activities, you came to know what kind of reactants we need to take in the form of solid state, in the form of aqueous solution, in the form of gaseous state. So, mentioning physical state of the reactants and products while writing equation is a very informative, and it gives clear picture about reaction. So, physical state of the reactants and products, some solid state. If reactants or products in solid state, we should write small s beside the chemical form of the reactants or product. Or down arrow mark. This also representation of solid. Next one, if it is a liquid, if the reactants or products in the form of liquids, we have to use small l. And if the reactants and products in the form of aqueous solution, then you should use symbol AQ. AQ. So if reactants are products in the form of gaseous state, we should use small g in the bracket or up arrow mark. Okay. Next one. If the reactants or if the products are formed in the form of precipitate, we should use, let me write here, precipitate. Symbolic representation is PPT, or down arrow mark, or in the form of solid you can represent. So this is the symbolic representation of physical states of the reactants and products. If the reactants are products in the form of solid state, we should use small s or down arrow mark. If it is liquid, small l. If it is gaseous solution, or if it is aqueous solution, you should use AQ. If it is gaseous form, then you should use small g or up arrow mark. If it is in the form of precipitate, you should use PPT, a down arrow mark, or S. So these are the symbolic representation of physical state of the reactants and products based on their physical state. Right. Next one, reaction conditions. Condition of the reaction. So we need to write on heating, applying electric energy, and using catalyst. These are the reaction conditions. So mentioning heating are necessary or not, and passes of electric current, or adding any catalyst to the reactor. Next, heat change. Say if it is exothermic or endothermic. If it is endothermic, we should add heat in reactant side. If it is exothermic reaction, we should add heat in product side. So let us understand with the help of few examples. Get ready. For example, hydrogen react with oxygen gives water. Hydrogen react with oxygen gives water. You must know how to balance the equation. This one is a balanced equation. Now let us make this equation more informative by indicating their physical state of the reactants and products. So hydrogen gas, we should keep small g in the bracket like this. Oxygen also gas, and water also available in the form of gaseous state. So these are the mentioning physical state of the reactant and product. Next, one more example. Hydrogen react with nitrogen gives ammonia. So let us balance the equation first of all. This one is a balanced equation. In this one, hydrogen is a gaseous state, nitrogen is a gas, and ammonia also is a gaseous state. Right? But reaction condition is it is occurs in the form of in the presence of iron. Iron act as a catalyst. Iron act as a catalyst. Without iron, so there is no formation of ammonia by the reaction between hydrogen and nitrogen. So here we mentioned physical state of the reactants and products and reaction condition as well. On heating also. Delta is a symbolic representation of heat. So that means we need to heat the mixture in the presence of iron. So then only we will get ammonia. So then what is meant by catalyst? Catalyst is a chemical substance which is added to chemical reaction to increase or decrease the rate of the reaction, to enhance or retard the rate of the reaction. So that itself cannot involve in the chemical reaction. Catalyst is a chemical substance which is added to chemical reaction to increase or decrease the rate of the reaction and which cannot involve in the reaction is called catalyst. Here, so iron, it doesn't take a part in a chemical reaction, but it increases the rate of the reaction. So that's why we need to add iron to these reactants in order to get ammonia. So this is a physical state and this one is reaction condition. Is it clear to you? Right. Next one. Decomposition of lead nitrate. So lead nitrate, PbNO3 taken twice, lead nitrate on heating gives lead oxide plus nitrogen dioxide plus oxygen. So first of all, let us balance the equation. 2, here 4. But this is a balanced chemical equation. So here we need to write the delta because of the symbolic representation heating. So on heating only we will get these products. Otherwise we will not get lead oxide or nitrogen dioxide or oxygen from the lead nitrate on heating. Reaction condition on heating. So next one, physical state. Lead nitrate in solid state, you will get lead oxide in solid state as well, nitrogen dioxide in gas form and oxygen in the form of gas. So this one is the reaction conditions, and next one is mentioning physical state of the reactants and products. Next, conversion of ethyl alcohol to ethanoic acid. Ethyl alcohol C2H5OH on heating in the presence of alkaline potassium permanganate KMnO4 or acidified acidified potassium dichromate K2Cr2O7, then you will get acetic acid. This one is a liquid, this one is a liquid. So here these two are acting as oxidizing agents. So this one is considered as oxidation of ethyl alcohol. Without adding alkaline potassium permanganate or acidified potassium dichromate, there is no conversion of ethyl alcohol to acetic acid. So these are the mentioning of reaction conditions. So this, if you mention all the physical states of the reactants and products or reaction conditions and catalyst dissolve, they give complete information regarding to reaction. So these are the points how to make the equations more informative. Is it clear to you, my dear? Right. So now let us have a talk of types of the reactions. So let us discuss one by one. So many types of reactions are there: combination reactions, decomposition reactions, displacement reactions, double displacement reactions, precipitation reactions, neutralization reactions, and redox reactions. So in this, now I'm going to explain combination reactions. Put it, combination reactions. Combination reactions. Combination reactions. Combination reactions. Those reactions in which two or more reactants combined give single product is called combination reaction. So those reactions in which two or more reactants combined together give single product. Combined together give single product is called combination reactions. So that means here number of equations are involved, two or more, but you will get only single product. So based on that we come to know this one is a combination reaction. Those reactions in which two or more reactants react together, combine together, give single product is called combination reactions. Example. Example. Burning of magnesium ribbon. Let us take one magnesium ribbon. Magnesium is available in the form of ribbon. Before going on burning the magnesium ribbon, we need to rub with sandpaper. So we need to rub with sandpaper. What is the reason behind that? Sandpaper, we need to rub with sandpaper because of generally metals are highly reactive. They have tendency to react with others in the presence of environment. So most of the metals are have tendency form oxide layer on the surface of them by react with oxygen present in the atmosphere. So same as in case of magnesium also taking place like that. So when magnesium ribbon exposed to environment for a considerable time, it may react with oxygen and produce magnesium oxide layer. Magnesium oxide layer. So this is the oxide layer. Magnesium oxide layer. So in this state, it has no tendency to burn. To make it magnesium ribbon as burn, we need to rub the magnesium ribbon with sandpaper. So that's why we need to rub the magnesium ribbon with sandpaper in order to remove protecting layer, that is magnesium oxide. So this is a very important bit. Why should the magnesium ribbon be cleaned before burning in air? To remove protecting layer, that is magnesium oxide. So take one magnesium ribbon and light it. So magnesium react with oxygen gives magnesium oxide. This is a balanced equation. If you want, you can mention the physical states: solid, gas, and this is a solid. This one, how many reactants are there? This is one of the reactant. So this is one of the reactant. This is the only single product. So this is a combination reaction. What is combination reaction? Those reactions in which two or more reactants react together, combine together, give a single product is called combination reaction. Here, the reaction between magnesium and oxygen is considered as combination reaction. So let us take one more example. So magnesium ribbon on combustion will get magnesium oxide, which is a white color powder. Please make a note of it. White. It is a white color powder. White powder. White powder. White powder. Now let us dissolve this white powder in water. So when magnesium oxide dissolved in water, you will get magnesium hydroxide. This is also example of combination reaction. So magnesium oxide, when dropped in water, you will get magnesium hydroxide. What is the common name of magnesium hydroxide? Yes, milk of magnesia. It is used as antacid. Milk of magnesia. Milk of magnesia. Make a note of it. Milk of magnesia. Milk of magnesia, which is used as antacid. Antacid. Milk of magnesia. If you want, you can mention the physical states. So magnesium oxide solid, water is liquid, you will get magnesium hydroxide in the form of aqueous solution. Right? So if you check the nature of the solution with red litmus paper, it changes to blue. That means it's a basic in nature. So that's why you can say generally metal oxides are basic in nature. So you will get this point in case of third chapter, metals or non-metals. So please make a note of it. Generally metal oxides are basic in nature. Generally metal oxides are basic in nature. Generally metal oxides are basic in nature. From this one, let us write one more equation. When burning magnesium ribbon is placed in the presence of nitrogen atmosphere, then magnesium react with nitrogen. Magnesium react with nitrogen gives magnesium nitrate. Magnesium nitrate. So this is also combination reaction. So this is exothermic reaction. Later on we will discuss what is the exo and endothermic reaction. This one is endothermic reaction. So please make a note of it. So a solid is a gas, this is a solid. So these are few examples of combination reaction. So now let us take few more examples. Please make a note of it. Right. Next one. Carbon. Let us take carbon. Carbon react with oxygen gives carbon dioxide. It's a combination reaction. Carbon is nothing but paper in the form of carbon is available in the form of paper, wood, water, whatever it is, right? So take one paper and burn it, you will get ash along with carbon dioxide. So carbon react with oxygen gives carbon dioxide. So this one is solid, this one is gas, this one is gas. This is a combination reaction because of here two reactants taking place in the reaction. You will get only one product. Next one. So carbon dioxide dissolved in water under high pressure, you will get carbonic acid, H2CO3, carbonic acid. Please make a note of it. Carbonic acid. Carbonic acid. This is a combination reaction. Two reactants and involving the reaction and you will get only one product, carbonic acid. So combination reaction. So physical states, carbon dioxide gas state, water is liquid, this one is in the form of aqueous solution, AQ. What is aqueous solution? Aqueous solution is nothing but the solution which is obtained anything dissolved in the water. If salt is dissolved in water, you will get aqueous solution of salt. If sugar is dissolved in water, you will get aqueous solution of sugar. If anything dissolved in water, that must be considered as its aqueous solution. Please keep that point in our mind. Right? Here, carbon dioxide when dissolved in water under high pressure, then you get carbonic acid. So if you test the nature of this solution, it turns blue litmus to red. Blue litmus to red. Blue litmus to red. So based on this equation, we can say generally non-metal oxides are acidic in nature. Make a note of it. Generally non-metal oxides are acidic in nature. Generally non-metal oxides are acidic in nature. Is it clear? Right. One more. Carbon react with oxygen, insufficient combustion, then you get carbon monoxide. Carbon monoxide is a combination as well. Carbon monoxide react with hydrogen in the presence of zinc oxide and chromium oxide, you will get methyl alcohol. 4 methyl alcohol. Please make a note of it. Methyl alcohol. Methyl alcohol, also called methanol. Methanol. This is a gas. It is in the form of liquid under high pressure, atmosphere pressure. So it's a combination reaction. One more example I would like to give combination reactions. Right? Dilution of calcium oxide in water. You will get calcium hydroxide. This one also example of combination reaction. So this is a solid, the liquid, this is the aqueous solution. So these are the